Okay, so now we're going to get into the basics of probability. Specifically, we're going to look at counting rules. So we need to be able to identify and count the sample space and the sample points so that we can determine probability. So we talked about that in our last videos, that we have to say, hey, what's the sample space, right? What are the possible outcomes? And then what are the sample points that we might be interested in? Because once we can understand those and define and identify those, we can then assign probabilities to determine, hey, what's the probability of this event? There's different ways of doing this. In this video, we're going to talk about the counting rule for multiple step experiments and trees. So let's look at an example. So the counting rule for multiple step experiments, right? This is the equation, if you will, for it. So the total number of outcomes, right, sample points, is given by n1 times n2 all the way up to nk, where n is the possible outcomes that you could get, and k is the number of steps. So let's look at an example. What is the number of experimental outcomes in an experiment involving tossing 2 coins? Right, so we have how many steps? We have 2, right? Because we're going to toss 2 coins, or we're going to toss a coin, right? And then we're going to toss a coin again, excuse me. So we have 2 steps, so that's what k is equal to. And then in each step, how many possible outcomes are there? That's our n value, right? There's 2. You could get a heads or you could get a tails. So, right, so what is this equal to, right? N1 times by N, right, 2, right, all the way up to K. Well, K is just 2. So, right, so we have N1 up to N, K equals 2. So each N, we already defined that, right? What are the outcomes? You could get a heads or tails, so there's 2 possible outcomes, right? So we're multiplying 2 by 2 because there's 2 steps, and in each step, right, there's 2 outcomes, so it's just 4. So, and we can visualize this very easily. So say we flip a coin, you could get a heads or a tails, right? And then in the second step, right, you flip a coin again, and you could get a heads or a tails. So here's the different outcomes, right? You could flip a head on the first trial, if you will, and the second one you can get a heads. That's a possible outcome. Or you could flip heads and then tails. That's another outcome. Or you could do a tails and a heads, or a tails and a tails, right? So here you have 4 different outcomes, and that's what we're interested in. The total number of experimental outcomes, right, is given by this equation here, right? And that's what we did. We solved it to get 4. And this is just an example showing, hey, here's the actual 4 outcomes that you could get. So the counting rule for multiple steps is important because it will tell you how many possible outcomes there are. Let's look at another example just to clarify this. So what is the number of experimental outcomes in an experiment involving tossing 6 coins, right? So there's 6 steps, k equals 6, and in each step, right, there are 2 possible outcomes. You could get a heads or a tails. So here's step 1, 2, 3, 4, 5, 6, right? So you just multiply 2 times 2 times 2 and so on to get 64. And that is it. That is the counting rule for multiple step experiments.